So we're solving systems of equations by substitution. And in order to do this, we're going to follow the steps, okay? So there's steps to solve the systems of equations by substitution. So number one, I grabbed the wrong thing. There it is. Okay. Number one, we are going to solve one of the equations for y if necessary. Sometimes it's already solved for x. So what we're trying to do is we're either trying to get a variable by itself. So we want to solve one of the equations for y equals if necessary. So we want to solve one of the equations for y equals if necessary. Okay, number two. What do y'all think it's going to be? It says blank the value for y in the second equation. Substitute. Good job. So we're going to substitute. Substitute the value of y in the second equation. Okay, number three. It says blank the new equation to find x. What do y'all think we're going to do with the new equation? We have to solve it. We have to solve the new equation. Because we're trying to find the value of x. Okay, number four. It says blank the value for x in either of the original equations to find the value of y. Substitute. What do y'all notice we're doing a lot of? What are we doing? Solving and substituting. All we're doing, solving and substituting. Okay, ready? Number five. Blank your answer. Blank your answer. Check your answer. Check your answer. We're checking our answer to substitute x and y in both of the original equations to make sure that they make the equations what? True. You sure we don't want to make them false? No, we want true equations. We want to make sure that the answers that we're getting are accurate, because it would be kind of silly if we were solving a bunch of stuff for stuff that didn't matter, right? So how does this pertain to us in real life? Can somebody give me an example of what substituting equations would look like, or solving for a system of substitution in real life? Does that make it kind of hard to see the purpose of doing this? Yeah? Okay, so let's think about it. Ready? And what's really cool is right now, I really want the little game thingy. This little guy on a skateboard, I figured I'd get that one. Okay, so what about a skateboard manufacturer introducing a new line of boards? The manufacturer tracks how much it costs, which is the amount it spends to make the boards, and the money that it's making, which is the amount it earns through sales of its boards. How can the company determine if it's making a profit? This is if you want to have a business and you want to sell a product, in order to figure out how much it costs to make that product versus how much it costs to make money from that product, you are going to have to use a system of equations. Let's look at another one. Oh, this one's making bike frames. Oh, this is a ticket to the circus. So if you ever want to work in the circus, just putting that out there. You want to be the strong man on the circus. In order to make money, the cost of a ticket to the circus is $25 for children and $50 for adults. That's ridiculous. It better be a very, very good circus. On a certain day, attendance at the circus is 2,000 people, and the total gate revenue is $70,000. How many children and how many adults bought tickets? You could set this up as an X for children. Every child is $25. So ready? 25X plus 50. What's our other one that we use? Y equals what? Would it be 2,000 or would it be 70,000? $70,000. But if you wanted to figure out the system of equations, it would be X, the amount of children, plus Y, the amount of adults, equals what? 2,000. And you could figure out how many adults and how many children went to the circus, and we could figure out how much each one costs. This is a system of linear equations, figuring out where they meet in the middle. Let's look at another one. Meal tickets. So the meal tickets at the circus cost $4 for children and $12 for adults. And if 1,650 meal tickets were bought for a total of $14,200, how many children and how many adults bought meal tickets? It sounds intense, doesn't it? But in all reality, what they're doing is they're saying, okay, if I have $4 per what? Child and 12 for each adult, so you have 4x 12y equals $14,000. Yes? But we only know that this many tickets were bought, right? So that means that X amount of tickets plus Y amount of tickets equals 1,650 tickets total. And if you took that and solved for X and Y, you could figure out how much of each they sold. It's the only thing that makes sense. So, look at this one. Jamal's choosing between two rental truck companies. The first, Keep On Trucking, that's funny, charges an upfront fee of $20. What's an upfront fee? That's always our what in our equation? Our y-intercept. It's always our b. And then they charge 59 cents per mile. So 59 is going to multiply times our what? 0.59. 59 cents per mile. So how do we write that in the equation? Y equals what? 0.59 x plus 20. And then Move It Your Way charges an upfront fee of $16 and then 63 cents a mile. Y equals 0.63 times x plus 16. And you could figure out when the both of them are going to charge the same amount, however many miles it's going to be. There are multiple opportunities for you to be able to use systems of equations in real life without it looking like a system of equations. But if you don't know how to do it algebraically, then there's no point. You can't graph everything. It's going to look kind of crazy. So let's go back to our paper. We're solving each system of equations by substitution. So we're substituting the values. We're going to solve, substitute, check. That's what we're going to do. So everybody look at number 1. solve one of the equations for y if necessary. Okay, do we need to solve any of the equations for y? Why not? We already have it. We already have one. Which one is it? Y equals 3x. Y equals 3x. Yes? Okay, if y equals 3x, what's our next step? We're supposed to what? Substitute the value for y into the second equation. Okay, guys, so what goes where?
3x goes to y.
So this goes here? Okay, so x plus 3x equals negative 32. We're substituting it in. What's step 3? What's step 3? Solve the new equation to find what? X. Okay, ready? So what's x plus 3x is? Now what? And what do you get? What do you get? X equals negative 8. Okay, so now what do I have to do? I have to take that value that I got for x, and I have to go back to one of the equations. Does it matter what equation that I use? No, it doesn't matter. It says either of the original equations. Everybody underline either for me up here. Either of the original equations. So we're going to go back to either of our original equation and plug in the value that we saw for x. So which equation do you want to use? The first one or the second one? The first one. Okay, let's go for it. I heard that one first. So y equals 3 times whatever the value of x is. So what's the value of y? What is the value of y? Negative 24, because what's 3 times negative 8? Negative 24. How do we check it? Well, if this is our new, so here's the system. I'm going to put it up here in a box in the corner. That way we can make sure that we have the right answer. Negative 8, comma, negative 24. How do we go and check our solution? Okay, so I'm going to write both my equations. Y equals 3 times x, x plus y equals negative 32. And we're going to take the values of x and y, and we are going to substitute them into our equation. So what's the value of x? Negative 8. What's the value of y? Negative 24 equals 3 times negative 8. Right now I'm just going to write them, and then we're going to solve them. So negative 8 plus negative 24 equals negative 32. So you can use your calculator if you need to. Negative 24 equals, what's 3 times negative 8? Negative 24, does that equal? Yes, check, got it right. Okay, next one. What's negative 8 plus negative 24? Does negative 32 equal negative 32? Yes. Good job. Okay, let's look at number 2. What's our first step? Solve one of the equations for what? Y. Do we need to do that? It says is if necessary. Do we need to solve anything for y? Why not? Because it's already done. Okay. Substitute the value for y in the second equation. How do I do this? Marla said that we should put them equal to each other. Anybody agree with her? Agree or disagree? Agree, okay. Why do you think we should do that, Marley? Yeah, so look, if y equals this amount, that means we can do exactly what we did over here and just bring it where the y is. So now we have 9 times x minus 2 equals 3 times x plus 10. From here, what do we need to do? Solve for x. Okay, so ready? If we're solving for x, what do? We're combining like terms across the equal sign. This is a two-step equation with variables on both sides. We've learned how to do this. Remember, you're going to combine your variables and combine your constants. You can use your box method if you need to. So you are trying to figure out how to make your x's be on one side and the numbers be on the other. So what's the first thing I'm moving? 9 times x, negative 2, 3 times x, 10. Everybody saying 2. Okay, let's go ahead and move the 2. Okay, so what do I have to move next? Okay, what do I do next? We solved, so now I have to substitute. Which equation do you want? First or second? Second one. Okay, so second equation. That means y equals 3 times our value for x, 2, plus 10. 3 times 2 is 6. 6 plus 10 is... Now we're going to what? We're going to check it. So I'm going to rewrite it with all of my information. 16 equals 9 times 2 minus 2. 16 equals 3 times 2 plus 10. Okay, ready? 16 equals 9 times 2 is 18. 18 minus 2. 16 equals 16. We got it right. Now we have 16 equals 3 times 2, which is 6, plus 10. 16 equals 16. We got it correct. Do you guys see what we're doing? Are you sure? Okay, let's go a little deeper. Number 3. Let's look at number 3. What do we do first? We have to solve for what? Y. Any of them that we need to solve for Y? Why not? It's already solved. We don't need to do anything. This one's already done. So now our second step is to substitute the value that we got for y, and we need to put it where? Where the y is. Right here. Right there. In a y. Yes? So we're going to rewrite the whole thing with the information that was with the y in the y. So 5 times x plus 6, open parentheses, because we're multiplying, minus x plus 4, close parentheses, equals 13. So I want you to go ahead and see if you can solve for the value of x, and see if you can solve for the value of y.
Not it. Pick someone, I don't know, number 530,820. No one to do math today. Who's doing it? Who explained it? Alright. What's your name's correct, Joel?
Yes.
Joel, alright, Joel can explain.
Yeah, I don't even know if I did it right though.
Joel, huh? I don't know, it's between her, I don't mind, let me see what you got.
Is it, okay, so I got y is -7 and x is 1. That's right, thank you. You got that? Okay, guys, how am I gonna start this?
Okay, just be like, okay, so your first step is.
Okay, so your first step, guys.
No, shut up.
I'm teaching.
Go, girl.
My bad. Can you get 5x? So you got, shush. What is 6 times negative x? You get negative 6x. So you can do negative 6x. 6 times 4 plus 24 equals 13. Okay. Makes it mixed up.
No, Julie, there's not supposed to be a plug.
Well, it's either way, it doesn't matter. Okay, so you get negative x plus 24, because you add your like terms, equals 13. And since we need to get the x by itself, you have to subtract 24 from both sides. Y'all cannot, I am so sorry.
Are you crooked?
I cannot see!
I know, but I understand.
There we go. Give me a second, guys. Okay, so you get negative x equals 13. Can y'all see it? I'm so sorry. Okay, so you get negative 11. Thank you. And then negative 1x the same as negative 1. So you get x equals 11. That's for the first one. And then I'm not gonna flip this. Okay, so then since you got your x value, you need to substitute it to get y. So you can do it for your first problem. You could do y equals negative, substitute. So it's 11, negative 11 plus 4. So you get y equals negative 7. And then you could check it. Do I have to check it? Oh my goodness gracious.
Can you put the answer in the top right corner real quick?
Oh my god.
That way you'll
So
read.
you get 11, negative 7. That's your answer. Did y'all get that?
Good job, Joel.
Y'all agree with her?
Okay.
Do you want me to do the check real quick?
Yeah, you can do it. You got that. She's like, yeah, you can do it.
Okay, so if we check it really quickly, because that's what we're gonna do, we're just gonna substitute the x and the y values back into the equation. So that means that negative 7 equals negative 11 plus 4. Negative 7 equals negative 7, that's correct. Then we have 5 times 11 plus 6 times negative 7 equals 13. 55 plus negative 42 equals 13. 55 plus negative 42 equals 13. 13 equals 13. Ta-da. Okay, ready? Let's turn said page. Okay, I'm gonna give you, we're gonna go on one problem that you have to, let me find it. Okay, so find the hardest problem on the page. The hardest problem on the page. I already know which one you're gonna pick. 5's the hardest one? Okay, so raise your hand for 5. Raise your hand for 8. 8 wins. Okay, so using the same steps, our job is to solve for one. Once we solve, we can substitute and solve for the other, and then we substitute it back in to figure out what the total situation is going on, okay? But I didn't show you how to solve for one, so let's look at it. We need to solve for either x or y. Which one do you want? I always solve for y, and the only reason why I solve for y is because I know how to solve for x a lot easier whenever it is in y-intercept form. My brain just has been trained that way. So I always put it in slope-intercept form. That is just how my brain works, especially because that's what you've already learned. You've already learned how to put it in slope-intercept form. So let's go ahead and just start there. Do you want to put the first one in slope-intercept form or the second one in slope-intercept form? First or second? Raise your hand for 1. Raise your hand for 2. Not everybody participated. Ready? Try again. Raise your hand for the first one. Raise your hand for the second one. Again, not everybody's participating. Let's try again. First one. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Second one. 1, 2, 3, 4, 5, 6, 7, 8. Oh, we win. Second one wins. Okay. So I'm going to go over here to the side. 6x plus 6 times y equals negative 6. That's a lot of 6's. Okay, now we're going to solve it exactly like we would if we were putting it in slope-intercept form. What's the first thing I move? The x, the ax. We subtract the 6x. And now we have 6 times y equals negative 6x minus 6. Now we have to keep going. What's our next step? Divide by 6. Good job. Okay, y equals negative x minus 1. Is that as scary as it looked? No. Okay, so now that we have the value of y, what can we do with it? Substitute it. You're going to substitute it into the other equation that you didn't solve for. Okay, so yes ma'am. Because we have to solve for y. Yes. Because your job is to figure out how much is the value of one ticket. Like in your brain. Like you won't know, you can't solve an entire equation if you don't know the value of one of them, right? So 1y equals negative x minus 1. No, because what's going to happen is if I did the same thing to the other one, I could plug that back into the second equation. It would work both ways. Watch. I'm going to do big brain for you really quickly. So we just got y equals negative x minus 1, right? What if we had done the other one? Sorry. Okay, so now you have a ridiculous amount of fractions, but you have your other equation all pretty and whatnot. I could take all of this information and plug it into this equation. Or I can take this information and plug it into the other equation, which was negative 3x minus 4 times negative x minus 1 equals 2. Either way, it doesn't matter. I'm gonna get the same answers. Because watch, I'm gonna solve them both. Y'all go ahead and do this one. I'm gonna solve this one over here, and I'm gonna see if we get the same number for x, okay? Because if they're a solution, we should get the same x value, correct? So y'all go ahead and solve this one. Go. Did y'all get x equals -2? Did you get x equals -2? Yes? Combine like terms. 4 minus 3. Yes? Look how much go they got. Did it matter? Look, I did a ridiculous way more work than y'all did. That's just because I'm making into fractions, because that's how my brain does it. Most of y'all would have just plugged that into a calculator and made your life so much easier. I didn't do that. I just did it by hand because that's how I know how to. But I solved it exactly the way that y'all did. I substituted the value of the equation back into the other equation. When I did that, I was able to do the math, and then I know how to do fractions by making common denominators, so that's what I did. I made a common denominator, and then I knew that 24 minus 18 was 6. 6 over 4 times x equals -3. I multiplied times the reciprocal, and I got x equals -2. Did we get the same answer? Did it matter what equation we did? No. And then I take that value for x, and then I go back and I plug it into whichever one I want to. I usually go back to the one that's simplified. Makes life a little bit easier. So y equals -2 minus 1. So y equals +2 minus 1, y equals 1. So you should get x as -2, 1. And then you come down here and you find your answer, and your answer is going to be an O. And for number 8, we did O. So I'm going to give you 20 minutes to work on this. I want you to work on it individually. I want to give you 20 minutes to work on it individually. And then I have another activity for you, okay? So 20 minutes, y'all can do this. I'm gonna leave this up on the board so that you can look at it. You're welcome to come and ask me questions at any time. Go.